Today in this video, we're going to be looking at testing a claim about a standard deviation or variance. So doing hypothesis testing when you're talking about standard deviations and variances. You may want to review Chapter 7, Section 5 if you don't recall how to look up some of these table numbers. If you recall from back then when we talked about the chi-squared distribution, we had to use a table. We will have to do that again today because you cannot do this stuff with the calculator, at least not easily. That being said, I also have to switch over from using the p-value method to using traditional just for this one when we come to our different types of doing hypothesis testing. So let's take a look at testing claims. So we've got a claim here. Some manufacturer is claiming that on a certain fishing line, it's a 4-pound test monofilament line, that the margin of error in the strength is less than plus or minus 5. Okay, so half a pound there, less than plus or minus half a pound. Okay, so there's a claim. Well, maybe you want to test that claim. If you go through that and take some samples, I got 10 spools, give the following strengths. And I'm going to have some data here. So we've got some strengths that have been tested. And of course, we've got some that are over and some that are under. There's some randomness involved with this here. And of course, this type of claim is a claim that deals with variance. How much variation is the manufacturer saying is possible? And how much variation are we seeing when we take the sample? For tests of these kind of claims, we have to use the chi-squared distribution like we did with confidence intervals. And again, we can't really use our calculators well for this, and you will have to use the table. If you need to pause, go, that's Chapter 7, Section 5, and review how to use that table. I will be using it today, but I don't go into all the details about it. So when we do this, like I said, we actually have to use the traditional method of testing hypotheses. There are some parts here that you're going to need to know. N is the sample size. S is the sample standard deviation. Of course, the relationship between standard deviation and variance is a squared/square root relationship. So this is the square of that. And of course, then we've got the population standard deviation and population variance. Again, we're just squaring it. The test statistic. Now, this is a formula that you will need to use for this. The test statistic for finding variance is going to be the chi-squared is equal to n, which is the sample size, minus 1. This is the degrees of freedom. If you recall, when we discussed the chi-squared before, the sample size less 1 was what we called the degrees of freedom. And I'm not going to go through and explain all that again, but that's what that is. And then, of course, here we've got the sample variance all over the population variance. And if you want, go ahead and go to page 759 of your textbook. I am going to be doing an example where I will use a table similar to that. It's not actually that table. It's one that I just took off the internet to use. But I'll be using that table. And remember when you're using this table that you're always getting the area to the right. That's kind of important. Again, you can go back and review that. For two-tailed tests, we do have to split the significance levels for both of them. So like for example, if you want to try this, go to your table and find an alpha of 0.05. The numbers you would actually use, half of that is 0.025. The other half of that is 0.975. You can take 100% or 1, take away this, gives you this one. And really, it's kind of written a little bit backwards. If you think about your normal curve here. So the 0.975, that's actually occurring way up here. The 0.025, that's occurring way down there. But they're backwards on your table, so that's why I have them written like that as compared to the graph. There is a reason that they're written that way on the table. Okay, so let me do a hypothesis test here using the chi-squared table, and I'm going to be switching back and forth a little bit between this screen and the next one. So sorry, it's going to be a little bit of a chaos, but I want to show you how to use the table, and I just can't fit it all onto this screen here. So we've got a dairy processing plant claims that the variance of the amount of fat in the whole milk has a variance of no more than 0.25. If 47 samples are taken with a variance of 0.27 at an alpha level of 0.05, is there enough statistical evidence to reject the plant's claim? Okay, so we're going to have to do two things. I know we haven't done a lot of hypothesis testing with the traditional method, but we're going to have to calculate the test statistic. We're also going to have to find the critical value. And I'm just going to really quick kind of draw this up here, what we're going to be doing. So a critical value, as a review, is a number that separates what's called the rejection region. So that would be over here. From the fail to reject region, that would be over here. And I'm just going to put a C here for critical value. And then we're going to have our test statistic, which we're going to use this formula for. And our test statistic, I'm going to use the letter T for that. If it falls out here someplace, then we would reject the null. But if it falls in here, then we fail to reject the null. So what we're really looking for is two numbers. One for our critical value, one for our test statistic. And we're looking to see how they compare. Which one's bigger, farther out to the right than the other one. So that's what's going on here. In this case, let's get our null stated here. Our null is that our variance is less than or equal. We've got to have the equals with it, 0.25, which means that our alternative will have to be greater than that. Okay, so that's what we're going to be using. This one is the claim right there. As we set this thing up, our degrees of freedom is always one smaller than our sample size. That's going to be 47. And we use this formula right here to calculate our test statistic, which is pretty straightforward. You just take your degrees of freedom, and of course, and then this is going to be our sample variance over our population variance, and you divide, and there we go. There's our test statistic. Well, now we need to compare this to a critical value. So we've got a test statistic. I just don't know if it's bigger or smaller than our critical value. We have to use the table for calculating our critical value. Now I'm going to kind of jump past this stuff here. You're kind of seeing me do my work. Here we go. Here's the table. And this one, I'm doing this on purpose, is a little bit more complicated than some others because of our sample size. Our degrees of freedom again was 46. And so if you look at this here, you look down, you're counting by ones, by ones, by ones, until, oh wait, here we're now counting by twos. Well, when we get way down here, I'm actually counting by tens. It goes from 40 to 50, when of course 46 is in between there someplace. So what I'm going to do is I'm going to come over here, and this has to do with the tail here, and again, the area to the right. That means that my test statistic is going to be somewhere in between there, between this 55.76 and the 67.5. Well, how do you find that? And again, this is why I'm doing this one. So again, if it wouldn't be this complicated if it was back here, but I want to show you how to do this one. It's skipping numbers. So what I have to do is I need to think of the difference between these two in increments of 10. Okay, so I'll simply just find the difference, and I'm going to divide it by 10, whatever the difference is. So that'll be a tenth. And then I'll need, since I want the number 46, I'll do 40, which is 55.76, plus 6/10. So I got to figure out what a tenth is. So again, the way I'm going to do that is I'm going to go ahead and I'm going to find the difference between the 67.5 and the 55.76. And I used it off a different table, which went 3 places. This one I'm stealing off the internet is going out 3. But I'll find the difference and divide by 10. So that gives me in tenths. And then I want 6 of them. So that's why I'm multiplying by 6. So this is 40 plus 6/10. There's my 6/10. So I got to add that to the number where 40 was, which again is right here. So that right there gives me, that is my critical value. Okay, now I'm going to go back to the other screen. And again, I'm sorry, this is a little bit of chaos here. I just didn't know a better way to do this. Okay, so we've got our critical value. There, I just wrote it here. It's what we just calculated. We've got our test statistic. Now, the critical value that separates the rejection region from the fail to reject. So that's right here. This is going to be my 62.8. Well, you can already see from my drawing because of my skipping back and forth, my test statistic did not get that far. So since it's in the fail to reject region, I'm just that. I'm going to fail to reject this one. If it had fallen out here, though, then we would say there would be sufficient evidence to reject. So that's how that works. You have to use a formula to calculate your test statistic. You use the table to calculate your critical value. And I showed you like the hard version just now. The what if it's not just a nice, easier number. Of course, you do have to keep track of where you're at with your alpha levels. And if that confused you where I was in the table, please go back to chapter 5, section 7. Chapter 7, section 5, a little dyslexia there. And review that one, and I go through more in detail about using the table, finding those columns. All right, I would like you to try one of these on your own. So please pause it right here, and you'll need your book for the table, and try to do this hypothesis test. All right, so here's our null and our alternative, and here's the test statistic. Okay, so I got to use my degrees of freedom, one less than the sample size, and then it's going to be my sample variance over my population variance, and those numbers are given. There's the standard deviation, so I have to square that number. I knew the standard deviation, but I need the variance, so I got to square that one. The other one was given for the actual population. And so then here is my test statistic. And then you got to use your table to get the critical value, which, because this one was not equal to is 2 tilde, you got to split that. And so you're going to look at your columns there. And the two numbers that you'll find are 12.4 and 33.9. So I'm going to make a little drawing over here. Okay, so 12.4, that would be like here. 39.3, that would be like here. And beyond that, in either direction is the rejection region. Between that is the fail to reject region. So if it's beyond either to the left or to the right, you'll reject your null. Okay, so we're going to take a look at this here. Well, of course, 42, that is beyond 39. So that would be in my rejection region. So you could go ahead and say that we reject the null, and then you could go ahead and make your conclusion. I didn't type out the conclusion here, but something to the effect of there is sufficient evidence to support and so on and so forth. You should know how to do that stuff by now. Okay, but that's how you would do that one there. If you end up with 2, you just have to see if it's beyond either one of them out in the rejection region. All right, so here's a few problems for you to maybe pick and try. Just do a couple more maybe. There are ones with data here if you want to try one with data. And that is it. I hope you have a good day.